Good day everyone, I am Jericho Pelayo from DSA 3 CS Horticulture. Agriculture is vital for food security and economic stability. Over millennia, humans have refined crops through selective breeding, enhancing yield, resilience, and nutritional value. Innovation like Green Revolution and modern biotechnology have accelerated in this progress, ensuring sustainable food production to meet the needs of a growing global population. And in this video, I discuss what is conventional plant breeding and how it helps the farmers to increase crop yields, improve resistance to pests and diseases, and enhance nutritional value, and what is the pedigree method. First, what is conventional plant breeding? Conventional plant breeding is a selective breeding of a plants over generation to improve desired traits without genetic modification. Next is the importance of conventional plant breeding. Conventional plant breeding is crucial for developing new crop varieties with desired traits like higher yield, disease resistance, and nutritional quality, ensuring food security and agricultural sustainability without genetic modification. Conventional plant breeding involves selecting plants with desirable traits and crossing them to create offspring with a combination of these traits. Through successive generation of controlled pollination and selection, breeders refine the traits they desire, leading to improved varieties for cultivation. Next is what is pedigree method. The pedigree method in plant breeding involves tracking and selecting superior individual plants across generations based on their ancestry and performance, aiming to develop improved varieties with desired traits. And next is how to do the pedigree method. First is the hybridization. In hybridization, the method starts with crossing two parent plants chosen for specific traits you want to combine in the offspring. This cross can be single cross or two inbred parents, and next is complex cross or more than two parents. Next is F1 generation. Seeds from the initial cross are planted and allowed to grow. The goal here is to maximize the number of seeds for further selection. And next is the F2 subsequent generation. This is where the core of the pedigree method happens. Individual plants are selected from F2 generation based on the traits you've interested in. These traits are preferably highly heritable, meaning they pass down from the parent to offspring with high degree of predictability. Next is the progeny testing and pedigree record. Each selected plant from the F2 generation is grown further and their offspring are evaluated. Here's a crucial aspect: a detailed record is maintained of the parentage of each plant, and this record allows you to track the lineage of desirable traits throughout the breeding process. Next is selection and advancement. As you evaluate progenies in each generation, you select those that exhibit the combination of traits you aiming for. These selected plants are grown again, and their progenies are analyzed in the next generation. And the last is yield testing. Once you have promising homozygous lines, they may undergo yield testing to assess their performance under specific growing condition. This helps to determine the line's overall suitability for commercial production. And the last is what is the advantages of pedigree method in our crops. First is selective breeding. It enables precise selection of parent plants with desired traits, leading to targeted improvement of specific characteristics like yield, disease resistance, and quality. Next is adaptability. It allows breeders to adapt crops to changing environmental conditions, market demand, and pest pressure by selecting for traits suited to specific regions or production system. And the last is compatibility. It produces offspring with predictable traits, facilitating the development of new cultivars tailored to meet the needs of farmers, consumers, and agro-industries. And once again, I am Jericho Belayo, and thank you for watching.